Okay. All right. Here's the first thing we need to recall from your past experience with this. Anybody remember what I squared equals? Okay. Need y'all to stop talking now. Shh. This is really all you need here. When we do any type of simplification through this whole thing, the only difference other than treating I as a variable is that I squared will equal -1. But having this as a definition, these are the four things you're going to be looking for in the first set of examples here. We know that I is going to equal I. We know I squared, this is I to the first, is going to equal -1. So what do you think I cubed is going to equal? No, use your definition. Yes, sir. Kyle. Nope. How about that? Yeah. Isn't this the same as I squared times I? Isn't I to the third the same as I squared times I? What does I squared equal? So -1 times I is -I. I'm just basing everything on this definition here. And then you just simplify. And the last one we need to do before they would start repeating again would be I to the fourth. What's I to the fourth going to equal? Very good. 1. Everybody understand why that equals 1? What's I to the fourth the same as? I squared times I squared, and what does I squared equal? So isn't -1 times -1 going to be 1? Okay. So you need to think in terms of these because of what we're getting ready to do here with the first example. Simplifying large exponents on I, let's look at A. If I have I to the 53rd, this is the important thing right here. That tells me every I to the fourth is going to equal what? 1. So look above your example. What do I tell you to do to help you simplify these? Yeah, rewrite this so that one of the exponents is a multiple of what? Because we know that any thing to the fourth, I to the fourth is going to be a 1, isn't it? That's why we're doing this. So what is the closest number to 53 that is a multiple of 4?
52.
Thank you. This is the same as I to the 52nd times I to the first, isn't it? Yes? Well, since this is a multiple of 4, what does I to the 52 equal? 1. So this answer is I. How many understood what I just did here? Nobody? Okay, well let's do another one. How about I to the 86th? Don't say the answer. Let people have a chance to think. I know it's not a popular thing, but try and think. You need to figure out the largest number, closest to 82, that is a multiple of 4, then separate I to the 86th. I just told you. No, I didn't. Did I tell you? Separate into a product so that the sum adds up to 86. So what would that product be before you give your answer? Yes. I to the 84 times I squared. Right? Now, since this is a multiple of 4, we know I to the fourth equals 1, this is going to be 1. Wouldn't 1 times 1 times 1, 21 times, still be 1? 4 goes into that 21 times evenly. So that means our answer is 1 times negative 1, which is negative 1. Because we know it's what you're looking for are these once you get past the power that's divisible by 4. All right, now let's see how to do a negative one. On the negative one, you want to go to the next highest, well, not actually the next highest, but the next negative number above negative 13 would be what? Negative 16? Wouldn't that be the next one that's divisible by 4? So to do negatives, you do it that way. For example, if I want to figure out I to the negative 13th, that's the same as I to the negative 16th times I to the what? Yeah, wouldn't it be I to the third? Now again, even if it's got a negative exponent, you all probably don't know this, but what does negative exponents do to anything? You remember that from Algebra 2? No? Anybody know what you do with the negative exponent to make it positive? Beg your pardon? Nope. Nobody remembers. Ask Mr. Clark if he taught this. You flip it. Anybody remember that now? Just listen. You flip it. It makes it positive. Now, isn't this still 1 here? And 1 over 1 is still 1. So your negative exponents are still going to equal 1 if they are a multiple of 4. So now we have this equals 1 times I to the third. And what do we know that I to the third equals? Negative I. So this answer is negative I. What is the fourth, or the next number we need to take it up to for the next one here? I'm going to erase this and have a little bit of room here. We have I to the negative 22nd. What product could I change that to so that we could figure this one out? I to the negative 24th is the next one up. And in reality, it's really the next one down because larger the negative, the smaller the number. But a lot of you wouldn't realize that. That's why I'm saying up. Now, what does it have to be times to still equal I to the 22nd? Negative 22nd. Yeah. I squared, right? Because when you multiply, you add exponents. So this is going to really equal what then? Right? What does this equal? 1. What does I squared equal? Negative 1. 1 times negative 1 is? All right, let's see if you got this. Do the next 4 on your own. So what is the product for the first one? No, I don't want the answer. I said, what is the product that leads you to the answer? So everybody can see where it comes from. Wouldn't it be I to the 36 times I to the third? So we know I to the 36 is 1. We know this is negative I. So our answer is negative I. How many got negative I? Give yourself a bonus point. What do we separate this one into? 96 and what? 3. So again, we get negative I, don't we? All right. What do we take this one to? Yep. I to the negative 20. I to the 3, or to the third. So this is, we know, is 1, and then we got negative I again, don't we? Is it going to happen again? Oh. Darn. How do we rewrite this one? I to the negative 56 times I squared. So in this case, it's going to be negative 1. Okay. How many got all 4 of those? You got it. All right. Let's go down. Go ahead and give yourself a bonus point for each one. I'll be generous. I shouldn't have to do the next examples. We'll just look at them and you write the answers down. I'm going to write them up here for the sake of people if they want to see it. But if we're adding, how many already know how to add complex numbers? What's the answer to A? The parentheses is just to separate the complex numbers. There's no distribution going on here and no multiplication. Yeah, you just add the real parts. 5 plus negative 2 is 3. And then negative 3i plus a positive 4i would be that. Everybody okay with that? We're just adding the real parts and the imaginary parts. Okay. Now this is too easy for bonus here. Now, I will give you bonus if you can subtract a b correctly. Okay. Just write the answer down, and then we'll see who's got it. Okay, we should be done by now. Do you have negative 4 plus 4i? Okay. And again, this must be written in a plus bi form when you do it. Give you 1 bonus point for that. All right, we should only have to do one of the problems at the bottom. If this is distribution or FOIL. We don't want to. That's a complex number in that form. A complex number is a combination of a real and imaginary. But that's... I'm sorry? No, that's a complex number. A complex number is made up of a real and an imaginary part. Say that one more time.
It would still be complex.
Yeah, but we don't do that, though. No. No. That's the final answer. There's no simplifying of this. This is it. All right, on letter A at the bottom, go ahead and FOIL that. Distribute. What's the only thing you need that I told you today to understand how to do this? I squared equals negative 1. So you've got to change all your I squareds. Simplify. How many already have an answer? All right, here's what you do. Distribute the 2 first. Distribute the negative 3i. And I'm not going to do this all at once here. I want you to see what happens. But the negative 3i times the negative 4i is positive 12i squared, but what's the I squared make the 12? So this actually becomes negative 12, which we can combine with the 14. So what is our final answer? 2 minus 29i. 1 bonus point. We don't need to do another of those, do we? Turn the page over. Now we're going to do division. I just did this in my Algebra 2 class not too long ago. Actually, all of this. We have a fraction line when we divide. In reality, we're not doing division like we would normally do division. Anybody remember that word from Honors Algebra 2? Should have seen it constantly. Conjugate. Here's where conjugates come from. This is the original conjugate situation. What does that equal? Anybody recognize that? That's the factorization of the difference of 2 squares. Anybody remember that? Wonderful. A minus b, a plus b, always is the same as a squared minus b squared. To divide, basically what I'm doing, and you do the same thing with radicals. We just did that in Algebra 2 this week. We don't really divide, we multiply by the conjugate so we can get rid of the i's in the denominator. So we're changing the form, not its value. Wouldn't squaring an I make it become negative 1? Does an I squared equal negative 1? That's why this works. So I need to multiply by the conjugate of the denominator. What would that be? No, the denominator. I need the conjugate of this. Would be 1 plus, no, you didn't pay attention up here. How does the conjugate change? A minus, and these are opposites, is all that's different. These are conjugates of each other right here. So this is the conjugate of this, and vice versa. This is the conjugate of that. But whatever I do to the bottom, got to do to the top. Go ahead and do that. Foil both of them. Go ahead and distribute. See what you get. Write your answer in A plus BI form. Could be, but you want it in the A plus BI form. You'll see how to do that. It's not hard. It's like if you have something minus something over a single number, do you know how to separate that into 2 fractions with a sign between it? So if we foil the top, looks like we're going to get 5 plus 10i minus 3i. And can I go ahead and make that a positive 6? Would everybody understand where that came from? Are you okay with that? Isn't negative 3i times positive 2i negative 6i squared, and the I squared makes the negative 6 positive. Then when we combine like terms, we would have 11 plus 7i. What did you get on the bottom? The I should be gone. Did you get a 5? Now, if you FOIL this and distribute like you did the top, that's fine. But you can really do this because they're conjugates. 1 squared is 1 minus, what's 2i squared? Squared. Isn't it 4i squared, which makes it negative 4? And what's 1 minus a negative 4? 5. And here's how you write it in a plus bi form. No, it's not an equation. You're changing the problem when you do that. You're changing the problem. That's the same thing like he was saying. No, why would I want to multiply everything by 5? Yeah, but whatever you can only do that when you do it to both sides of an equation. You're changing the value of the problem. Because what am I really multiplying by here? What is something over itself still equal? And isn't 1 times anything still the same thing? So I'm not changing its value, just its form. You're mixing up the idea of clearing a fraction in an equality because it's okay to do something to both sides. You can't do that just to a phrase or an expression. All right, let's have you do the next one on your own. See if you can do that one and get your answer for bonus. Everybody understands conjugate now, right? Some of you will get pretty good at this and be able to do them in your head, I'm sure. Just be careful and don't make little mistakes when you do that. So do you get 26 on top for the real part? How many got 26? And then I'm going to rewrite this in a second. Well, let's just go ahead and do it this way. We'll do the bottom in a second. And then for your I, or your imaginary term, you got negative 21 and a positive 8, don't we? So it'll be negative 13. So that's going to be a minus. Now all I need to do is figure out my denominator. A squared minus this squared would be a negative 16, wouldn't it? So when you add these, what do we get? And there's your A plus BI form.
Every one of those is about 13. You've got
Now,
like 13 out of that.
Well, but that's different. Yes, we can. That's different than what you wanted. Yeah. Y'all really don't have any math sense about this, do you? You don't know when to and when not to, do you? The other one wasn't, they didn't have any, we didn't have something in the bottom to divide in the top from the first one. You wanted to factor the 4 out.
Right. Well, yeah.
So there's nothing to simplify. No. Your change, if you can't cancel the 4, can you?
Okay. I see what you're saying.
So all you're doing is changing its form, and we can't even use it in that form. We've got to have it in A plus BI form. You factor a 4 out, we can't do anything with that. Does that make sense? This is just reducing a fraction. That's mathematics. That's always been around. And we're not multiplying by anything. We're not changing the that's just like reducing 4 over 8. You're going to make it 1/2. It's still 1/2 either way. Does that make sense? Okay. So yes, now we can, but we're not doing it to all 4. We're not dividing 13 out all 4 either. We're just simplifying this fraction. That's what we're doing. 13 will go into this twice and into this 5, won't it? So yes, I'm just reducing a fraction. 13 goes into that how many times? So that leaves me an I. And I'm sorry, this should be a 5. So what's the final answer? Yeah, this should be a 5. 13 goes into that 5 times, so we have this. So yes, this is in a situation where you can. But the others are different. Your situation wasn't an equation. It had to be an equation to do things to both sides. Okay. Now we got one more example. By the way, give yourself 2 bonus points if you got all the way on this one. This one takes a lot more work here. Example 5, letter A. Now we're given what it says, the quadratic equation. We want to write the quadratic equation if we're given the solutions were 3 plus I and 3 minus I. And what are those? They're conjugates, yes. And I don't know if you remember this from Algebra 2, but when you had a quadratic equation like this factored, remember this is, you factored it, and then remember how you said each factor equal to 0? And your 2 answers were 4 and 3, right? Because they became opposite. So let's say I was given these to begin with, and I want to write the equation they came from. So I'd put 4 back in here as x minus 4, wouldn't I? I put 3 back in here as x minus 3. Then I'd have to FOIL this. So this would end up being x squared minus 7x plus 12 equals 0, and that's the equation that these came from. All right, now we got to do that with these. So, since I said in my directions I want an equation, that means we have an equal sign. So we have x minus this one times x minus this one. Same things we would do with the 4 and the 3, right? See, these solutions are complex numbers, so they are a little more complex, no pun intended. Now we need to simplify that. There are a couple of ways you could do this. To me, the easiest way is to get rid of these parentheses first by distributing this negative. So this would really be x minus 3 minus I. Does everybody see what I'm doing? This would be what? X minus 3 plus I. All I did was distribute that minus sign, get rid of the parentheses. Now you just got a bunch of distribution and combine like terms. So you're going to have to take x times all 3 of these. See what we get. X squared minus 3x plus xi or ix, it doesn't matter how you write that. Now do the negative 3, and I like to put them under my like terms as I'm doing it. Negative 3 times x would be negative 3x, wouldn't that go under there? Then we have negative 3 times negative 3 is positive 9. We don't have any constant terms in the other situation, the other tier. Then you've got negative 3 times I, which is negative 3i. I don't see any of those either. So I'm going to put that out there. Now we have to distribute this. So we have negative I times x, which is negative xi, so that's going to go under there. Then I have negative I times negative 3, positive 3i. Yes? Go over here. See, if we do this correctly, we should get a quadratic equation with no i's in it, which is going to happen. We got one more thing to multiply. Negative I times I would be negative I squared, which would really be positive 1, which would go under the 9. Now, if I did this correctly, I should get a quadratic equation with no i's. So what's our final answer? So we'll have x squared minus 6x plus 10, and if you stop there, guess what? And some of you are still going to do it. This is not right yet. What did the directions say to write? An equation. And to have an equation, yes, you have to have an equal sign. And remember, we're writing a quadratic, and so it's equal to 0. If you took this and did the quadratic formula, x equals negative b plus or minus the square root all over 2a, you would get these two things right here. All right. I don't have your homework assignment up there yet, so I'll write it up there, but I do have your sheet stapled to your paper. And since I'm going to lose my seniors and juniors today, 6th period, aren't I? Or no, that's tomorrow, I mean. Isn't that tomorrow? I thought the juniors had to go. Oh, is it just juniors and sophomores? No, no, no. The seniors, I thought, had to pass it on. Oh, so is it just the senior class officers? Anyway. I'm losing people tomorrow in class, so I'm not going to make this due till Tuesday. But that means your quiz is Tuesday. Okay? I'm going to write it up on the board before you leave so you'll have it here.